All right. So let's look at it. Our main aim is to make sure that this 10 raised to the power here and this 10 raised to the power here are the same. So students, this one, it depends on you. It's your own decision. You can change both of them to 10 raised to the power 2, or you change both of them to 10 raised to the power -3, depending on how you want to solve it. But we are going to arrive at the same answer. So I'm going to solve them in all those two ways for you to see them clearly. First thing is I'm going to change both of them to 10 raised to the power 2, meaning that I'm not going to change this part. It's already with 10 raised to the power 2. I'm going to change this part to 10 raised to the power 2, and then look at what will happen. Now, this is -3. What do you think what I do will change this one? All right, let's try and change this decimal to a standard form. We are going to move the decimal here. We have from our previous lessons with indices, this is going to increase the whole thing to 10 raised to the power -4. So instead of moving the decimal here, when we move it to this side, it becomes smaller, and it means this one is going to reduce. So let's move it to this side. All right, so what shows these two figures are the same? So I'm going to do the expansion for you to see. First, this -3 describes how small the number is. So we are going to make it really small. How many times are we going to move? 3 times. So now the decimal is here. We have 0.0. Wow. Okay. So these figures, if you are moving them back, we have 1, 2, 3. Definitely we have 0.1 times 10 raised to the power 3. Okay, -3. That's good. Let's compare this with that and see if these two numbers would also be the same. Now here's going to be 2. We have 1, 2. And look at these 3 zeros here. And then we have these 3 zeros here. So basically, they are the same. I like to go over so that it becomes simpler for you. All right. Now, listen. The decimal point is here. This is -3. Now I'm going to pick a very simple figure, describe it, and then we can come to this work. Let's pick a number. We have 2. 2 is the same as 2.0. So now, if you want to move this point here, what do you think will happen to the power of 10? It's going to be positive. So if we want to reduce this one, we have to move here so that this one will reduce, or we are going to add +1. Or you can decide to change this one to a standard form and later work with this, okay? But we are moving to -2, so we are moving to this side rather. Okay. Now look at the movement. If we move here, the figure is going to look bigger. It's going to really increase this one to -4. But if we move here, it's going to be smaller. So this one is going to reduce to show that the number is also increasing. So as you decrease here, this place will increase. As you increase here, this place will also what? Increase. So please look at it. If we move the number to this side, we are going to have 1.0, which is bigger. If it's 1.0, it means this part is supposed to go to -4 to show that it wasn't like that. We have made it bigger. So we are going to make it a little bit smaller because we want to make the same thing, 10 raised to the power -2. So let's move it to this side. Now we have the point here. All right, so now both of them are in 10 raised to the power minus 2. We can add. Okay, let's look at the addition. We write one of these 10 raised to the power negative 2 with the product sign. They all contain the product sign, it has to be maintained. Then let's add the decimals. 5 plus 1, we have 6. 1 plus 0, we have 1. The decimals are in line. We are doing the right thing. 2 plus 0, we have 2. Now this is our final answer. Remember that in this particular work, I tried as much as possible to make sure that these 10 raised to the power are the same. So we change them to 10 raised to the power negative 2. Now what if a student wants to change both of them to 10 raised to the power 3? That is the next thing I'm about doing. So please look at it, follow up, and then you choose how you really want to go about it. Okay. So in our subsequent example, I said if we move this one to this side, it means that we are going to reduce this one by 1. It means it's going to negative 4. If we move here, it becomes 0.01. This side is going to be negative 2. So when we move here, in actual fact, if it's negative 3, it's going to increase to negative 2. Now let's come here. So what are we going to do to make this one negative 3? If we move here, it's going to appear bigger, 21.5. It was actually 2.15. So the moment it becomes 21.15, we know that no, we have increased the figure. So we have to bring more negative to show that the figure was actually small. So let's move here. We have, it means the negatives are going to decrease by 1. And minus 2 minus 1 is going to be minus 3. Good. So now what is happening is that we have 10 raised to the power minus 3, 4. Both of them easy to add. It's the same thing for subtraction. We are going to solve only one example when we get to the subtraction. Then we move to multiplication and then division. 21.5 plus 0.1. So we have 0.1 times 10 raised to the power minus 3. Make sure the decimals are in line and bring your addition sign. Good. Look at this work again. 5 plus 1, we have 6. Then we have 21.6 times 10 raised to the power negative 3. This answer here is 2.16 10 raised to the power negative 2. Now it means we can do something to this. What do we do? If we make it smaller, it means that this number is going to increase by 1. Okay, so let's do that for this one. We have 2.16 times 10 raised to the power minus 2 as required. So today we've gone through how to add two standard form figures. This number was in standard form, this wasn't, but they have been written in index notation. We've been able to add. So you go through this example, you can always go back if you think you are really getting confused, okay? And make sure this work is very easy for you. The procedure is first, make sure the 10 raised to the power are the same. Then you add the decimal part of the work times 1 of the 10 raised to the power, whatever figure you have changed it to, okay? Now let's go to subtraction. Okay. So here we have 3.6 times 10 raised to the power negative 1 minus 1.2 times 10 raised to the power minus 2. We have another case. The 10 raised to the power are different, so we are going to make them the same. Now I said, if you move this number here, it will appear bigger. It's going to be 12. Now if it appears bigger, it means it was a lie. So this one is going to reduce to minus 3. This one, let's make it smaller. If it becomes smaller, it means the number was bigger. So it's also a lie. So what are you going to do? This one is also going to increase by 1. So now I want to make them the same. We have 10 raised to the power negative 1, 10 raised to the power negative 2. All right, so which are we changing? I prefer to change this one to 10 raised to the power negative 2. So it means I'm going to go here. It appears bigger. This one will reduce by 1. When I say reduce by 1 minus 1 is minus 2. And that is what I mean by reduce by 1. So here we have all right, so just like the addition, we can solve. We write one of these, then we subtract whatever we have here. Let's go and borrow 1 from this. We have 5 here, then we have 10. We are working in base 10. So any number you borrow is equivalent to 10. So we have 10 minus 2, we have 8. 35 minus 1, we have 34. The decimal point is at the right place. So good. We've gone to the subtraction smoothly. You can always go back. And don't forget to subscribe to this channel, okay? I would like you to send me feedbacks, then I can really help you out, okay? All right. What's the next operation we would like to go to? Let's go to multiplication, and then we are going to end with division. Okay, so pay attention. Good. Multiplication of numbers in index notation. Good. So let's look at the work we have here. We are supposed to multiply all these numbers and represent our answer in a standard form. So I'd like to add that instruction. All right, so we are going to simplify this and leave our answer in a standard form. Okay, so let's pick the figure. Now, we have 2.5 times 10 raised to the power 3 times 3 times 10 raised to the power 3. So what I'd like you guys to do is that let's push all the numbers without the 10 raised to the power to one side, move these numbers to one side, and see if we can work with them. So here we have this 2.5 is going to be multiplying by the 3, and these two look alike. They are going to play with each other. So let's try. Good. Now this is very easy to multiply, the first two. So let's look at the multiplication. You can forget about the decimal point. We multiply and later we bring the decimal point. So now let's look at it. 3, 5, we have 15. Remember that one. 3, 2, we have 6 plus 1, 7. It means 25 times 3 is 75. But let's look at the number of decimal places in each of them. This one has no decimal place. This one has 1 decimal place. So we are going to move our answer to 1 decimal place. So from here to here, we have 7.5. So it means 2.5 times 3 will give us 7.5. Now when you come to the 10 raised to the power, if you looked at our previous video, we've been handling indices. You can really go there, look at the laws, master them, and let them come and help you here. Now we have 10 raised to the power 3 times 10 raised to the power 3. How many times are these things going to multiply each other? We are going to have 6 times. So we are going to write only one of the 10 and add the powers from the product law. Same basis, you write one of the base, you add the powers. All right, so our final answer, we have 7.5 times 10 raised to the power 6. This is very easy. Now let's look at another example. Then we move straight to the division. All right, so here we have 0.6 times 10 raised to the power negative 2. We have 3.4 times 10 raised to the power minus 3. So I told you with multiplication, we can decide to group them and still multiply. We are going to arrive at the same answer. Multiplication is commutative, so please stick with it and let's do that. So we are going to change the ones without the 10 raised to the power to one side, then we multiply these twins to also one side. Good. If you've been able to express it this way, it means you are on the right track. Keep believing in yourself, be focused, and let's get the concept right. Okay, so we are going to multiply these two. You have 0.6 times 3.4. If you have a problem, forget about the decimal point, multiply the whole numbers in there, and then let's count the number of decimal points. So we have here, we have 0.6. If we take the decimal away, we have 6. If we take the decimal away from this, we have 34. So I'm going to multiply 6 times 34, and I'm going to count the number of decimal places in those two examples. (34 times 6). All right, so if you are really not good with your maths, you can decide to expand this to 30 plus 4. I think for now, JHS, you should be very good with multiplication. 6 times 4 is 24. 4, remember 2 here. 6 times 3 is 18, plus 2, we have 20. So for these two, we are going to write 204. But they contain decimals, so we are going to count the number of decimal places each of them had, put them together, and move. This one has only one figure after the decimal point. This also have one figure after the decimal point. So together they have 2 decimal places. So we are going to move from the right to the left 2 times and introduce our decimal point. Good. So now we have 2.04. Okay, so 2.04 for these two, and here we can add them. The bases are the same and they are being multiplied. We have minus 2 plus minus 3. Minus 2 plus minus 3. We have 2 negatives adding, so it's still going to be what? Negative. Now these two, you can assume the negatives as electrons. So we have electrons are negatively charged. So 2 electrons plus 3 electrons, we have 5 electrons. And electrons are negatively charged. So the negative 5 is here. And this is our final answer. Good. Now we are moving on to division, which is what really counts in your exam. So you pay attention and let's go through the concept. Get it right, practice a lot. If you want to be good in maths, you have to practice it daily, and then you are going to be better than I am. Thank you. Let's move on and then go through the division. Wow, so we are in division now. So what are we going to divide? They are going to give us some questions and ask us to solve. So please make sure you understand the concept, you apply them, and then it becomes very easier for you. All right, so here we have 10.15 times 10 raised to the power negative 3. All being divided by 5 times 10 raised to the power 2. The work has been arranged in a nice way. They've made sure these numbers are in line. The 10 raised to the power also in line. Good to go. Now what are we going to divide? We are going to divide this number by 5 and work with these because the same basis, indices. So for these, we can't divide them unless we apply the indices laws. They have the same basis. Now, 10.15 divided by 5. So look at how I'm going to go through them. Even though they have a decimal point, I'm going to make sure the decimal point is intact, and I will divide. 5 goes into 10, we have 2. I will not say 5 goes into 15. After the decimal point, you have to take your time and divide. 5 goes into 1, it's not possible, that is 0. Remember this same number, 1. Now we have 1. Now 1 here we have base 10, so this side is 15. 5 goes into 15, we have 3. So we have 3 here. And 5 goes into ace of 1. So for this simplification, we have 2.03. Remember, after the decimal point, I didn't solve them together. I had to take my time, go through this one, and then the 5. Now, if the two numbers are divided, it means that we are going to write one of the base and then subtract the powers. Make sure you put the new power you are bringing from the denominator in a bracket so that you don't really get it wrong. So if this was minus 2, the minus 2 would be in the bracket here till I'm done, and I can now remove the bracket. Now, what is minus 3 minus 2? We have minus 5. You can review your notes on integers, and then you can get this right easily. And so this is our final answer. Now, we are going to pick a question that is very close to something that has happened in BEC. Look at the whole thing. Let's go through together and get it right. Okay, so here we have 15.3 times 10 raised to the power negative 2, 5.4 times 10 raised to the power minus 3, all being divided by 3 times 10 raised to the power negative 3, 0.9 times 10 raised to the power negative 1. If you want this work to be very easier for you, I would like to group all the numbers, these numbers to one side, and then the 10 raised to the power to the other side, and then we'll solve. All right, so this is what we are going to have, and this is really good. Now, the next thing is these figures contain decimals. It makes it very, very difficult to work with. Well, we can take the decimals away. Okay, so let's try and take the decimals away. Now, if we move this one to this side, we are going to have times 10 raised to the power negative 1, because we moved ones. And we have moved from the left to the right. So we have the same thing can be done here. We have then we go and work on the denominator. This is very good. It's a whole number. It makes the division very easier. We can move here, and it's also going to be negative. How many times? Once. All right. Now we are going to write the whole numbers here. This 10 is now in their midst. We are going to write them together. So I'm going to write 153 times 54. And I'm going to write only one of the 10s and then add all the powers. 1, 2, 3, 4. All right, so I've done the same thing for the numerator part and the denominator part. Let's look at these numbers. Now, in BC, we are going to be giving you numbers that you can straight ahead divide because you are not going to be using calculators. So make sure you take the decimal out of the numbers. Don't multiply them because they are going to be very huge. You cannot divide. Leave them just like they are in the work and see if you can have numbers that can divide each other, or you can have a common divisor that can work with any of the numerators and the denominator at the same time. 153. We want to see if it's divisible by this 3. We say a number is divisible by 3 if the digit sum is a multiple of 3. So let's add the digits. 1 plus 5 is 6, plus 3 is 9. It means 3 can divide this number. So we are going to take our time and divide. 3 goes into itself 1. 3 goes into the first two number, which is 15, 5. There's no remainder. 3 goes into 3, 1. So it means 3 going into 153 will be 51. That's good. This number is 54. If you want to know if 9 can divide a number, add the digits. If it's a multiple of 9, it means 9 can divide that. 5 plus 4 is 9. It means 9 can divide 54. 9 goes into itself 1. 9 goes into 54 how many times? And that is 6 times. Wow. So all these numbers are gone. We are doing a simplification. It's getting easier. Now let's go to the 10 raised to the power and see what is happening there. -1, -1, -2, and then -3. So together we have -7. So here we multiply these two. All right, so we have -1 plus -1, we have -2 plus -3, we have -5. So the -5 is here. Now, after multiplying these two, we are good to go. We are going to work on this part using indices. So what is 51 times 6? We are going to take our time and multiply. 6 times 1 is 6. 6 times 5 is 30. Good. We are left with this part. They have the same basis. What is happening between them? They are dividing. And we said division is repeated subtraction. So we are going to subtract the powers. The first power minus the second power. Don't forget, when you are bringing the second power, put it in the brackets so that you don't forget the minus signs, okay? This minus is for the log, and this -5 is for the exponent down here. Don't confuse yourself with how many minus you are supposed to write. This minus is coming from the law. Laws of indices. With division law, if the bases are the same, we subtract the powers. So this subtraction is talking about these two having the same basis, but having a division between them. All right, let's move on. Now we have -7 minus -5. The two negatives are coming together. It's going to be positive. Good. Now we have -7 plus 5, and that is -2. All right. Now this answer is not bad, but it's not in a standard form. Now, when they ask you to leave this answer in a standard form, you have the 10 raised to the power here. Leave this side, and let's look at this side. Okay, we said there's a decimal here. We don't want to write it. If you want to, you can do that, okay? So I'm going to change this 306 to a standard form, and then I'll multiply my result by this. All right, so I'm moving from right to left. That is the right way. That is positive. So now we have 10 raised to the power 2 against this one. Laws of indices, multiplication, we are going to add them. And this is the preferred answer. This answer is in a standard form. So thank you for going through all these operations with me. Remember to stick with the concept. We've done standard form. We've explained what a standard form means. We've done operations under standard form. And so then we've gone through addition, subtraction, multiplication, and then division. So make sure you go through the video. You can always play it back and look at where you really don't understand. Send me feedbacks. I'll get back to you. Don't forget to subscribe. That is the first thing you have to do if you really want to see our subsequent videos and then benefit from them. All right, so in my next videos, I have a quest to look at Venn diagram so you can really follow up. Make sure you really get in with your questions and let me see how best I can help you with them. Thank you very much and have a wonderful time learning. Good.